Have you ever wondered what's really powering all the incredible advances we're seeing in robotics? I mean, we see these amazing machines that can perceive, decide, and act in the real world, and it seriously feels like we're living in the future. But what if I told you there's a hidden hunger, a secret weakness holding them all back?
And let's be clear about one thing. The age of advanced intelligent robots is no longer just sci-fi. It's happening right here, right now. They're getting smarter, more capable, and woven into our lives every single day. But behind all that incredible progress lies one single massive bottleneck.
You see, for all their sophisticated hardware and absolutely brilliant algorithms, there's one thing preventing them from reaching their full potential. It's that hidden hunger I mentioned, a fundamental need that just isn't being met. So what is it? What's the big secret?
Well, it all comes down to data. That's it. Specifically, a profound lack of the right kind of data. This is the central challenge, the great dilemma that the entire robotics industry is racing to solve. They're literally starving for information.
The problem really breaks down into two main parts. First, there's just a severe shortage of the specialized, high-quality data that robots need to learn. And second, the data that does exist, it's often scattered, poorly organized, and just plain difficult to use effectively. So we've got a supply problem and an efficiency problem, a double whammy.
And here's what makes this so incredibly difficult. Robot data isn't just a bunch of images or text like you'd use for other AI. No way. It's what we call multimodal. It's blending information from vision, touch, language, and laser sensors all perfectly synchronized to a real-world environment. It has to capture the logic of a task, not just what something looks like. It's a whole different beast.
To really get a sense of the scale of this problem, let's talk numbers. Right now, the entire industry has access to less than 2 million known trajectories. And a trajectory is basically just a recorded example of a robot completing a task. Now, 2 million might sound like a lot, but trust me, it's a drop in the ocean.
Because to properly train the kind of huge general-purpose models that are going to power the next generation of robots, we need over 100 million trajectories. Let that sink in. We have 2 million, but we need 100 million. That is a 50-fold gap. This is the data famine at the very heart of robotics.
So the big question is, how do we fix this, right? How do we go from a data famine to a data feast? Well, it all starts with a blueprint, a set of rules for what good, high-quality robot data needs to look like. And this blueprint is built on 4 core pillars. First, scale and coverage. That's getting to that 100 million trajectory goal across all sorts of different scenarios. Second, multimodal alignment, making sure all that sensor data is perfectly synced up. Third is versatility, so the data can work on pretty much any robot, not just one specific model. And finally, closed-loop usability, which creates this awesome feedback loop to constantly improve the system. So basically, you need data that's massive, synchronized, universal, and always getting smarter. Okay, meeting those requirements is not easy. It actually demands building a whole new kind of infrastructure, what you could call a full-stack, end-to-end data factory designed specifically for creating robot intelligence. Let's take a look at what that actually means.
Think of this pipeline as having 4 main stages. It kicks off with collection, which is just gathering all the raw data from tons of different sources. Then it moves to processing, where that raw data gets cleaned, labeled, and beefed up using AI. Third is management, using powerful tools like data lakes to store and organize everything so it's easy to find. And finally, you have training, where all that beautiful, pristine data is used to build and refine the actual robot models. And the collection part alone is just fascinating. It's not one single method. Teams are sifting through and refining public data. They're crawling the web for useful content, and they're even building these custom factories with super high-precision motion capture systems. And get this, some are even using decentralized Web3 networks to bring in thousands of data collectors from all over the world. How cool is that?
Now, with a problem this big and a solution this complex, you can bet there's a lot of money involved. Solving this data dilemma isn't just a technical challenge, it's a massive business opportunity. We're talking about a true digital gold rush.
To put it in perspective, just look at the wider AI training market. It was worth $5.5 billion in 2023 and is projected to double to $11 billion by 2027. This explosive growth is the wave that the robot data industry is riding right now.
And the investments, they are staggering. Just look at the potential cost for a single project aiming to collect 500 million trajectories. The data collection alone is estimated at $182 million. You add in R&D and operations, and you're looking at a total investment of $230 million. This is a very, very high-stakes game.
This huge opportunity has attracted a few different kinds of players. On one hand, you've got companies that focus on software, offering cloud-based tools and APIs that anyone can use. On the other hand, you have companies taking a more hands-on approach, providing totally customized services and building entire data factories for their clients from the ground up. So what's the end game in all of this? This quote really says it all. The ambition is to become the Hugging Face plus ImageNet of robotics. Now, for anyone who doesn't know, ImageNet was the giant image library that basically kicked off the modern AI revolution, and Hugging Face is the go-to platform where developers share AI models. The goal here is to create that same kind of foundational open ecosystem, but specifically for robot data.
But that brings us to the final critical question. Building this ecosystem is a monumental task that's going to cost billions. But if they succeed, if they can actually build this ImageNet for robots, will that be the key that finally unlocks the full world-changing potential of true robot intelligence? That's the challenge, and honestly, the future of robotics is hanging in the balance.